Hello everyone, welcome to the mathematical discussion on the role of mathematics in engineering. In this lecture series today we are going to talk about the importance of differential calculus when it comes to thermodynamics and heat transfer. As you know, in mechanical engineering, heat transfer problems are very important areas where we concentrate more and more research are done. So when I talk about heat transfer, what really happens? There is a flow of heat from one point to the other. So how to measure it, how to understand the rate of change. So the rate of heat flow, in order to understand the rate of heat flow, it is very important to study the flow. So in those areas we use the concept of differential calculus. As you very well know, differential calculus derivative ideas, the origin of it is to understand the rate of change, and further you can understand the temperature change. So again, if I talk about temperature change, so we are going to understand, we are going to measure the rate of temperature change, how the temperature change happens. As I told you, in differential calculus we have two areas. One is ordinary differential calculus and partial differential calculus. In most of the problems, when you come across in heat transfer, the problems are likely to have more than one independent variable. So in those areas we use the concept of partial derivatives to analyze multivariate problems, multivariate systems, in order to derive solutions for it. So in those places we use the concept of partial derivatives. We have unique methodologies according to the situation we can apply. So it is very important to a researcher to master in these areas. For example, we have heat equations, we have various heat equation types according to the problem what we are going to study. So heat and mass transfer problems are very important, in which the flow can be turbulent or streamlined. We can study about the viscosity, we can study about the temperature change. So lots and lots of things can be worked out, and we can do computational works of mathematical tools with the importance of differential calculus. So as a researcher, it is important to understand how the transfer happens, what kind of fluid is flowing, whether it is a compressible or incompressible fluid, so its properties, the properties of the fluids before moving into the problem. So you should know what kind of flow it is, so and whether there is a magnetic field involved, or so what kind of the problem we are going to study. So it is very important to analyze these things before going to work with fluid flow. So in fluid mechanics, when we talk about the importance of differential calculus in fluid mechanics, first of all we should understand the fluid flow. So you very well know Navier-Stokes equations are very important when we talk about the mathematical modeling towards fluid flow. So once if the mathematical modeling is done using the concepts of Navier-Stokes equations, further we can understand the profile of the fluid flow. For example, velocity profile, in order to understand the fluid velocity change, how the fluid varies with respect to velocity. So how is the velocity change happens, how is the pressure change happens, how is the temperature change happens. So the importance of it, the properties of it, the properties of understanding the pressure and temperature is very important when you talk about fluid mechanics. So also when you talk about the fluid flow according to the velocity profile, further we have to understand what the viscosity of that particular fluid, the density of that fluid. So all these parameters is a way to understand the solution for that particular problem. So in order to predict solutions for the particular problem, we should very clearly understand what kind of fluid we are going to measure in. So in these areas, if you are well versed, if you have a master in it, then you can work with the differential calculus, which will make you understand and make you realize a beautiful outcomes, beautiful results for such kind of problems. So interpretation and result discussion can be easily done when we use differential calculus with the governing equations, which can along with the knowledge of all these what I said, to understand and to structure the systems. So thank you for listening. Thank you.